Welcome to part 2 of chemical reaction engineering. In case you haven't seen part 1, I would request you to go through it before you commence on this one. Now, as we have spoken about the heat of reaction, let me now tell you a small trick. Often you'll get MCQ questions in many places. Say there is a reaction A plus B gives C. Okay. So what kind of pressure do you expect? What kind of nature of this chemical reaction in terms of temperature do you expect? Now it's seen that reactions in which the number of moles decrease. See, the number of moles here is 2 and the number of moles here is 1. Okay. So the reactions in which the number of moles decrease are usually exothermic in nature. Usually. This is not always the case. Okay. Usually this is the case. And in such cases, a high pressure is generally preferred. Alright. Now, suppose there is a case where there is A plus B gives 2C plus D. So the number of moles over here is just 2, whereas here it's 3. So what is happening is there has been an increase in the number of moles. So the kind of reaction that we're looking at is usually endothermic in nature, and the pressure that we prefer to have is a low pressure. Okay. So this is one thing that you can remember. Next, let's go through with another part of this. Okay, now you have studied different theories. Okay, different theories about chemical reaction, about activation energy. So I hope you know what activation energy is. It is the energy required to activate a product to a certain level. So I'll tell you about one important theory first, that is the Arrhenius theory. So the formula K equals to, this is small k, mind it, small k equals to small k0 exponential minus EA by RT. Here K is the rate constant. Okay. K0 is a frequency factor. It's a constant value that may or may not be provided to you. Exponential of minus EA. EA is nothing but your activation energy. R is of course the universal gas constant, and T is your temperature, usually in the absolute scale. Okay, temperature in Kelvin. Now rate constant, rate constant just determines the pace at which your reaction is occurring. So oftentimes you are said, suppose there is a reaction whose rate constant at a particular temperature is given and its activation energy is also given. So you are provided with the rate constant of the same reaction at a different temperature, say T2, and you are supposed to calculate the activation energy in that case. So you can calculate it by this ratio. Say K1 for the first one be K0 exponential of minus EA by RT1, right? Because at temperature T1 the reaction has a rate constant K1, and making a ratio K2, K0 remains same. Say if it's not mentioned, then keep it same. Okay, if it's mentioned that K0 for reaction 1 and K0 for reaction 2 varies by a certain factor, then apply that. Exponential of minus EA2 by RT2. Okay, EA1 and EA2. So you have to find the ratio between EA2 and EA1. So you have to solve this. If nothing is mentioned, remember K01 equals to K02, the frequency factor. Okay, remember that. So you need to calculate the ratio of minus EA1 and EA2. You can do that by solving this equation. In the next video, I'll talk to you about the collision theory and the transition state theory.